Alright, so I'm going to help you get ready for your lab tomorrow. And so you have several things to do for your pre-lab that you can find at your class. Thought I had it open. Okay, so the first thing that you are supposed to do is to make the truth tables for these two functions, I believe. Let's see if that is correct. I don't know what I just did. Okay, so build truth tables for two functions and determine at least one input combination that will distinguish a circuit for F from a circuit for G. That is, when the same input values for F. Okay, all right. So we're not going to do these exact same circuits, but we will do a similar idea. So let's do instead F of RST equals R plus S bar and R no, let's not do that. Let's do R S bar or R bar T, and then G of R S T is R S or R T. Yeah, okay, alright. And hopefully I didn't design something that is not indistinguishable. Hold on, let me pause it and just make sure.
Press.
Okay, so yeah, these will be fine. Alright, so we need to build truth tables for these. So R, S, T, and then because I can't remember anything anymore, I like to have everything that I might possibly need. So I'll need an R bar, I'll need an S bar, I'll need an RS bar, I'll need an R bar T, I'll need an RS, and I'll need an RT, and finally I'll need an RS bar. Or R bar T, which is F, and I'll need an RS or RT, which is G. So you don't have to write all those. I just have gotten to where I can't remember anything anymore. So I'll put every possible value and do them in order. So this is the order that they would be if these were binary numbers. And now R bar will be the complement of R. So that will be 11110000. S bar will be the complement of S, so it'll be 110000. 1100. R S bar, so wherever either R or S bar is 0, it'll be 0. So R is 0 for all these first 4. And then for the last 4, S bar is 0 here and here. And for these two right here, both R and S bar are 1, so that'll be 1. Because remember, the AND is 1 when both of them are 1. If either one is a 0, then the AND is 0. Here we have another AND, so it'll be 0 when either R bar or T is 0. So R bar. And I just did R and not R bar. R bar would be 0 for the last 4. And T is 0 here and here. And right in this row, they both T and R bar are 1, and in this bar, they're both 1. R and S, both 1, will be 0 here, because R is 0 there. S is 0 here, but in the last 2, they're both 1. R and T, so the first 4 will be 0, and then T is 0 here and here. So in this row and this row, they're both 1. Now RS bar or R bar T, so that's this column and this column, and it's an OR. So this will be 1 if either one of them is 1. So if there's a 1 in either column, it'll be 1 because it's an OR. And then for the last column, RS or RT, so these last two right here. Looks like that's it. Okay, so I'm going to do something right now just to double check and make sure that I got those right. You won't know what this means yet. If you can figure out from what I'm doing, I'll be really impressed, because the first time I saw this, it took me forever to figure out what it was going on. But you'll learn this later. And it's just going to be a way for me to check and make sure that I got this right, because I'm very tired. Okay. RS bar. Okay, so that one appears to be right. also appears to be right. Yep. Okay, so that does appear to be right. Okay, so now let's look at what the next instructions say. So this, again, this is not, these are not your functions, so yours will not be the same as this. Determine at least one input combination that will distinguish a circuit for F from a circuit for G. That is, the same input values to a circuit for F and a circuit for G will produce different outputs. Okay, so for mine, there are a number of different choices. So if I have any place where these outputs are different, so that would be this row, this row, this row, this row, or this row, any of those could work to distinguish function F from function G. So I'll just use this top one, which is R bar S bar T, and that would give us F equals 1 and G equals 0. Draw a circuit of logic gates for F and a circuit of logic gates for G. Do not simplify either F or G. Oh. I wonder if I was supposed to make them be able to share a gate. Okay, so F has, so we have R, S, and T. And for R, I have both a complemented and a non-complemented form. And for S, I only have a complemented form. And I have R and S bar. And I have R bar T. And I have the OR of those two. And that's F. And then G, did I not put any NOT gates? I did not put any NOT gates. So that's RS and RT. And then I have the OR of this. The middle site has a list of chips available for you in the lab and data sheets for these labs. Among other things, the data sheet tells you the pins for VCC, ground, and inputs and outputs for the gates in the chip. You need to examine the data sheets of the chip you'll be using, then decide which gates each chip you'll be using, and finally decide how to connect the pins from your circuit. Make sure you connect wires to VCC and ground for each of the chips as well. Choose either function F or G. Map your logic circuit to IC chips. And okay, so I will pick what time is it? I have time. I will pick F. So F, I need an AND gate, a NOT gate, and an OR gate. So, and 2 input and 2 input OR. And I would have thought I would remember which chips were what, but for some reason I am not remembering. So let me go back to the class, and I go to lab resources, and chips available in the lab. Okay, so the inverter I just got 74 X XL X04. The AND, I need a 2-input AND. I see my 2-input OR is 74X32. And 74X32. That was the OR. And the AND is 74X08. And so I'll open up the data sheets for those. Okay, so now I'll draw my circuit a little bit bigger. And I will call my NOT gate chip 1, chip 2, and my AND gate is chip 3. So these will both be chip 3. This is my OR gate, it'll be chip 2. These will both be chip 1. And if I look at my NOT gate, I see that the logic on it is 1A is the input and 1Y is the NOT of 1A, 2A is the input, 2Y is the NOT, and I see that 1A that's the wrong chip, we want the top chip. 1A is pin 1, 1Y is pin 2. Pause for just a second. I just did a whole lot of stuff without recording it, so but I'm recording this on Zoom, and so I'm gonna upload the Zoom recording instead of my Camtasia recording rather than going back and redoing it. But basically what I just did on the Zoom recording is I mapped out our circuit, and so some of you may really still need to see that, so you might want to check that recording out. Okay, and then let's see, what else do we have? Write a simplified expression for h of x, y, z equals the sum of some min terms. Okay. So h of x, y, z equals the sum of some min terms. I will say we're going to be the sum of the min terms 0, 4, 6, and 7. Let's make sure those aren't the same as yours. Nope. Okay. And we want to write a simplified expression for that. So min-term 0. So min-term 0, that means that it's 0, 0, 0. So these, all three of them are complemented. Min-term 4, that is in binary, that's 1, 0, 0. So if we think about in binary, we have 3 digits. That's the zeros place, the ones place. That's, oh, I guess if we have, yeah, 1, 2, 4. This is, sorry, the ones place, the twos place, and the fours place in binary. And so to make the number 4, I'll put a 1 in the fours place and 0 elsewhere. So that means that my first variable will be not complemented, and then my second two variables will be complemented. 6 is 4 plus 2, so that's 1, 1, 0. So that would be x, y, and a not z. And 7 is 1, 1, 1. That's 4 plus 2 plus 1, so all not complemented. And let's simplify this. So notice that these two are the same except for the middle term, so we don't need that middle term. Um, and I'm trying to think, is this and this, is that the exclusive OR of X, Y, and Z? So, let's see. So the exclusive OR is where you have an odd number of ones, and so no, so that's not the exclusive OR. I feel like it should be something. So that would be the not. Oh, no. That would be the not of X or Y or Z. It is the not of that by De Morgan's law. I don't know if that helps us simplify it. Yeah, so you don't know what I did right there, so don't worry about it. But I could do this. And remember, I can write this as, so I rewrote x z bar as x y z bar and x y bar z. And now I can say that these two are the same, except for the y, so that gives me an xz, which is not what I ended up over there. And okay, so I have to stop here. I'm going to go ahead and upload what I've got, and then I will try to finish this later.